Okay, hello everyone. Sorry for we had a short technical issues, but we can start. The timer already started, so I will start as well. Hello and welcome to the last session on Micronaut at GeeCON this year, and this talk will be dedicated to one specific feature called declarative HTTP client. And before we move, I just want to remind you that we are using Slido, where you can ask questions, and we will get to them at the end of the presentation. But as you have seen, there is a Spring data in the title of this presentation, and I would like to give you a short story why I use this metaphor. So I have a friend, let's call him Dwight, and one day he asked me about to just suggest him something in his Spring Boot application. He's a junior Java developer. He has only hands-on experience in Spring Boot, and he asked me if I could suggest him some changes in REST template. He was using Spring REST template, and I shown him something in Micronaut, which is blurred for a purpose. You don't have to try to focus your eyes to see the details, because we will reveal the details in the live coding session in just a moment. But when Dwight saw how this problem can be solved with the declarative client, he said that it looks just like Spring Data, because that was his metaphor. He was working with Spring Data, so this solution to the common problem, which is communicating between two and basically multiple microservices, was something that in Micronaut with declarative client looks to him like just like Spring Data. So this presentation has 4 objectives, which I would like to explain in the beginning. So first of all, we're gonna explore the basics of Micronaut framework through the live coding. We're not gonna go deep into every specific feature, into every specific Micronaut thing, but we will touch many interesting features, not only the declarative client, but regarding declarative client, I want to show you what are the benefits of using this approach. But this is not the marketing presentation, and that's why I also want to explain what may go wrong. And there are a few traps which are pretty painful if we don't pay too much attention. And last but not least, in the end, we're gonna do some kind of like a bonus for this presentation, where we're gonna take the code that we are gonna implement, and we are gonna to use it in completely different framework outside of Micronaut. And it's all because I want you to level up your Micronaut skills. It doesn't matter if you've never seen Micronaut in action, maybe you have some experience with Micronaut. I can guarantee you that you will find something useful in this presentation today. So what we are gonna build, we will implement the demo app, this one. And there will be 2 scenarios that we will be taking a look into. The first one is we will be sending client users GET requests from the client, from the terminal, to our demo app. And what this demo app is gonna do is it will take this request and it will send it to some kind of user's API. You can think of it as some third-party API. Maybe this is some microservice running in your ecosystem. And as you can see, we will also add some API key, because this user's API requires authorization, which is not something that our demo application requires. And what we will get in response from that user's API is, first of all, we will get a response header, target host, and we'll get some small JSON array with containing objects with only 4 fields: UUID, name, email, and created by. And we're gonna just pass through this body to our client, and we also we are gonna rewrite this response header. But that's not all. We will also create users using this API integration. So we will accept post requests from our client, only name and email. We will add the API key, and we will send it to the user's API, and we will get the response from that user's API, populating it to our client. And Of course, these are the happy paths. This sounds very simple, but we're gonna also look into some problems. So first of all, what happens if user's API does not respond? A network is not reliable. Problems with communication and network happens all the time, so we have to be prepared for that. So what happens if we ask for users and there is no response from user's API? What happens if we try to create users and the communication is broken? We will use, there is no silver bullet solution to that problem, but we will try to find some way to fix that problem using integration with Amazon SQS. We're going to also look into how we can tweak and tune our HTTP client so that we can run multiple requests in a more effective way. And last but not least, we are also going to integrate the same code, no code changes, but we only some configuration, and we will move our HTTP client to the microservice-like scenario where we will use service discovery to communicate with multiple instances of this user's API. Okay, so that's all if it comes to slides to this moment. Let's try and write some code. Here I have this user's API is basically written in Micronaut. It's a simple project using Micronaut security, Micronaut data, some open API integration. There is a bonus which I won't show you right now what it contains, but we will create a new Micronaut application, and Vlad shown us how to use the Micronaut launcher. I'm going to use the CLI client. So we will use the MN command line client to create a new app with Java 17. Let's call it demo. This is no features, no extra features, just basic Micronaut application that once created, we will go here to link the Gradle project in just a second so that we can. Of course, I cannot see it like that. I will switch back in just a second. Where's link? Okay, now we can go back to presentation mode. And we can refresh dependencies. So by default, if you create a new Micronaut project, second, my microphone just jumped out of me. Sorry for. Okay, sorry for that. So when you create a new Micronaut project, what we get by default is only one application class. And as you can see, this is just a regular Java class with static void main method, nothing fancy inside. So if we go back to the presentation, let's start with implementing this communication for client users in our project. And we will start with implementing the declarative client right away. So I'm going to create an interface. I will call it users API HTTP client. Okay, the interface is ready, and to create the declarative client, all I have to use is the client annotation. For now, I will just hard code the location of this service so that we can tweak it later on. And now we need to implement the methods that we are going to use. So we had those two methods. One is the get method to users endpoint. And here I'm going to just return the list of some users, calling this method list. Okay. Here I will create inline record called user, containing those required fields. So UUID, not this one, string name, string email, and string created by. Okay. And as with records, we have to just end it up them like that. Let's import the list. And now, whenever we create objects, either if these are the records or just regular project classes, it's always worth adding the introspected annotation. This is Micronaut annotation. And one thing worth mentioning, there was this question about the difference between Spring Boot and Micronaut. One of the things Micronaut does is it uses annotation processing. So these three annotations that you see right now, client, get, not introspected as well, these annotations will be processed at the compilation time, right? And if it comes to this user record, what we are going to use it for is we will be serializing this object to a JSON form. And to do it without using reflection, we need to add introspected annotation so that annotation processor can generate introspected metadata at the compilation time. So whenever you serialize something to JSON, or if you deserialize JSON to some object, always remember to add introspected annotation. Then we will add the create method, which will be a post method to the same endpoint, right, users. And here I'm gonna accept a body, which will be called create user request. Okay, and again, I'm also gonna use record for that. Why not? I don't see anything on my screen, so I have to look there. Sorry for that. That's, you know, the problems when your screen has a higher definition than the screen you mirror to, and something doesn't work. But no problem. And string email, okay? And again, as I mentioned earlier, we're gonna add introspected annotation here. What else I can do, since we will be accepting some input from users, let's add validation. And now what we can do is we can add some simple validation rules. So for instance, if it comes to name, let's say it's not empty. The same for email. Not empty, and also it has to pass the regular JavaX email validation. Last but not least, as you have seen here on slides, we have this API key that we also have to add to our requests. And we have to add this header to every request. Luckily, with the declarative client, I can specify a header here at the interface level. Let's add it right here, XAPI key. And for the value, I could either just add it right here, but that won't be very nice way to do it. So let's just take it out from here and let's define configuration property, users API key. Okay. Once we do it, we can go to application YAML, and here we can simply add it. And there is one thing worth mentioning. When it comes to Micronaut configuration, when we do it like that, here I'm operating in application YAML file, but there's no problem to add, let's say, application test YAML. This test will define the profile. So if my application runs with the test profile, it will overwrite any configuration from this the default application YAML file. But also what I can do is I can export users API key and variable. It will also override whatever is in this application YAML file. As well as, since Micronaut is just a regular Java application which is started with Java -jar, I can also pass it as users API key, right? So this way I can also override this value, which makes now this configuration pretty simple. Okay, so our client is the basic client is implemented, and now let's use it. So for that we will need some controller, which we can create right here. So let's call it users controller. The class can be final, and let's add controller annotation. It will be client users, here I'm gonna inject our user's API HTTP client. No annotation needed. I will just inject it through constructor, and here create some kind of proxy. So I'm gonna return a list of users. This user exactly. Let's call it list, and we will just return the output from the client. And the same goes with post request. We're going to return user. The method is called create. There is a body, the same body that we used in the HTTP client. We don't have to, here we don't have to run validation at that level because the validation will be run when we call a client, so no duplication needed. And in those few steps, we have a controller ready to test. Let me make sure that the user's API is running. It is running on the port that we defined in the configuration. So now we can start Micronaut application. To call this endpoint, I'm going to use the tool called HTTPy. This is, if you've never seen it, this is the curl on steroids, which makes running those HTTP requests much simpler. So let's see what happens if I send get request to the client users. We get an empty array, just as expected. Now let's create a user. So now I'm going to send the post method, and I'm going to create a new user. Let's see what happens if I forgot about adding an email. We have a validation which says that email cannot be empty. So let's see what happens if I pass incorrect email. Of course, the email validation also works in this case. So now we can create a regular user. We get the response here created by this Mark Spencer. This information comes from the API key, because this API key, this user's API has very simple authorization where there is a key assigned to some person. This is a Mark Spencer. That's why we know who created that user. And now if we go to this get request, we can see that we get a list of users. Perfect. But the thing is, using declarative HTTP client that works with solid types, like those concrete types, like user or maybe list of users, we are losing one, we are sacrificing one thing. The thing is we cannot get any details about the HTTP response. And like here we have on this chart, we want to get the target host from the response and we want to populate it, right? How can we do it with the declarative client? And if in some cases we need more information about the response object, HTTP response wrapper comes to the rescue. So if we go to this HTTP client, and if I replace this type with HTTP response of list of users, now I can get the detailed information from that user's API. So let's do the following. Here I'm gonna capture the response to this variable, and here I will return a new HTTP response, because whenever you want to specify some custom header, you have to return the HTTP response object. That's one way how to do it. So if it comes to status, I will simply populate the status from the response. When it comes to body, I will do the same. I will populate the body from the response. And now I can specify my header, which is x target host. And the value for that header, I'm going to get it from the response, which is held under the target host. Now I need to specify the default value to avoid null pointer exceptions. So I will say that this is the of type string, and the default value is an empty string. And of course I need to make that method to return, in this case, mutable HTTP response. But if we go now and if we restart the application, And when I call this endpoint again, now we can see that the expected header was populated. We will use this header later on when we connect with service discovery to see which instance responds with the body. Okay. There are a few things that still look not very nice. One of them is hard-coded URL for the client. I mean, you can always, one thing that is not covered in this presentation, but the thing is you can always inject the HTTP client and use this annotation just to specify the location. It's very useful for testing when you want to just use some service and you don't need any declarative client. This is the fast way how to do it. But if it comes to creating production-ready code, it's better to do it in a proper way. So instead of defining fixed URL here, let's create a named declarative client. Now I added the name to this client, users API. And when I do it, I can go back to application YAML, and here under the Micronaut key, we have Micronaut HTTP services. And here is a map of all of predefined and custom-defined services. So if I add this user's API here, what I can do is I can simply define the URL right here. This gives me this benefit that I can always rewrite it whenever I want, depending on environment, etc. So this is a very good starting point. But I'm not only limited to that. I can specify connection timeout. I can specify read timeout. And I can also specify event loop group. And this is the first trap I would like to make you aware of. So the Micronaut HTTP client uses netty, and it uses event loop and event loop groups to perform all communication. And there is one tricky thing. If we don't specify event loop group, Micronaut will use the default one. And the default one is also used by the request handler. So what may happen is the following. Here we have a hypothetical illustration of our request that comes in. Now take a look what happens during this request processing. You can see that the first thread, this event loop group has 5 threads, 5 event loops. So the first thread is blocked because it processes the incoming request. And now we trigger the declarative client, which also needs a thread from this event loop group. So until it finishes processing, it occupies the second thread from that event loop. Now we can imagine what happens if we are running on only a single thread in that event loop group. We will just have a live log situation, and our HTTP client will never be able to trigger the request. Plus, if we have like here 5 threads only, you can see how much we are limited if it comes to how many concurrent requests we are able to handle. There are ways to fix it. The simplest one, and something that we should probably do almost always, is we can define our custom event loop group. Here I just add a name, users API. And now if we go under the Micronaut, we have Micronaut netty event loops. And here I can specify the same name, users API. Here I can choose an executor. Let's decide that this HTTP client will be running on the IO thread pool. This is the default thread pool that is designed to handle blocking operations. HTTP call is a blocking operation, especially if we do it in a blocking manner. So we have this executor IO, and also let's define that we will only occupy one thread from that IO executor. Also, what we can do, this will be useful for later testing, I'm going to specify that the default event loop group runs only on a single thread. So by design, our application right now will only consume 2 threads by design. Okay? And before we run a quick test, let's go back to the logback configuration so that we can have, we can see some logs from the Micronaut HTTP client. And now it's time to restart the application. And if we run the call again here, now you can see that in logs, we can see that the this HTTP client used IO executor thread number 1, because what happens right now, if we go back to our illustration, here's what's happening. The request comes in, and now the same blocking operation is delegated not to the second NIO event loop group thread, but to this IO executor thread. And you know, on the surface it may look very similar, but the difference is huge, because if it comes to event loop, there is one thing we have to remember: event loop should never be blocked, and at least this thing prevents us from blocking the event loop group. However, the perfect situation is the following. Now imagine if we could achieve something like that. So take a look what happens. The blocking operation is performed on the IO executor thread, but the thread that handles the incoming request, when it waits for the response from the blocking client, it is ready to handle some other job. It's not blocking. So the question is it possible for us to achieve it? And luckily it is possible, because, and also just to have the better illustration of what may go wrong, let's use Siege command line tool. This is the tool that we can use to perform multiple concurrent requests. And here what I'm going to do is I will send 100 concurrent requests to our application, and we will see what happens. So now you can see this is our current implementation with one thread in the default event loop group and one thread for the user's API declarative client. So here what happens is basically the event loop always has to wait until the call to user's API is done. And in this case, what we can get if it comes to best performance is probably, let's see what happens if I send 1,000 concurrent requests. But I guess they should finish maybe, I was about to say in 5 seconds, but we can see that it wasn't possible. So it's like 100 transactions per second. It's not very efficient, but it may work for us. You know, if I have an application that has an endpoint that is called only 2 times a day, it will be perfectly fine, right? But the thing is, if my endpoint is called much more often, then we have to take this into account. So how can we solve this problem? There are 2 ways. Let's start with the first one. So the first thing is, what we can do is we can add the executes on annotation to our controller action, and here I can specify on which thread pool should this action be performed. Task executors, not scheduler, of course. Here. So in this case, what will happen is now we will be non-blocking, because the body of this method will be executed on the IO thread pool, and our event loop that handles incoming requests will be ready to handle another incoming connections. So if we restart this application, we will see much better results, I hope. Let's see if the demo gods are on our side. First of all, let's see if the regular call works. It works. Let's send 100 requests. And now you can see that the processing is much faster. I guess we can easily send like 1,000 requests to this application. And let me recall that we are still, but there is one, of course, difference. When I added this executes on annotation, what happened is now I'm consuming all available threads from the IO thread pool. So I'm not running on a one thread anymore in this case. I use only one thread from the IO thread pool to use the connection with user's API. But what happens by default, now I will reuse as many threads as possible from the IO thread pool, which also might be a problem because some other processes and some other endpoints may also want to consume threads from the IO thread pool. So what we could do is we could either, instead of just using IO thread pool, IO executor right here, we could define our custom one, or we could be even more fine-grained, and we could go back to the situation where we use only 2 threads with the same performance by doing one specific thing. Let's add one more method to our HTTP client that will also send a GET request to the user's endpoint, but this time I'm gonna return a publisher. This is the type coming from reactive streams, and I'm gonna return a publisher of user. Let's call it list async. Okay, we have this new method. Let's go back to controller. I will add one more method right here. Forgive me, incorrect naming for the RESTful endpoint. We will just add async right here. It's just for demo purpose, so it should be okay. And here, let's call it list async. And what I'm gonna do is I will just simply return the output from this list async method. Let's see what happens now. First of all, we're gonna check with the HTTP if the async returns any response. It still returns the expected response. And now let's see what happens if I send 100 requests to this endpoint. And let's see what happens if I send 1,000. So now what happens is we are running on 2 threads only, because whenever we return any reactive type, it might be publisher, it might be completable future, it might be flowable from RxJava, it might be what we have. We have monoflux in Project Reactor. Whenever you return some so-called reactive type, what Micronaut will do is it will, first of all, it will do it in a non-blocking manner, and it will subscribe to this reactive type so that it will be processed on the thread pool that is associated with the HTTP client, which in our case is the IO thread pool specifically. So now you can see we get throughput at level of like 1,500 transactions per second, which is much better than 100 requests per second that we get with the blocking client. I'm not saying that you always have to go into reactive async processing. The good point is that, as you can see here, with not that many changes, we can reuse our client, we can return reactive types, and as you will see at the end of this presentation, this reactive type will also work in the other framework that we're gonna use at the end. Okay, if we go back to the presentation, we also have this thing called service discovery. And what service discovery solves is that, especially in microservices world, we are running applications, we are running multiple instances, we are running on some random hosts or ports that we have no idea what the target host or port is. And we can simulate the same situation with the following thing. Let's kill this application, and now I'm gonna start this Micronaut application with port -1, which means that it will bind to one of the randomly picked 3 ports. And let's also start another instance of the same user's API application. So now we have 2 applications running. If we go here to console, here we can see that these 2 instances are registered to console. And now the question is, how can we make our application aware of the service discovery? The thing is pretty simple. First of all, we need to add one dependency to the build Gradle, which is the Micronaut discovery client. Let's refresh Gradle dependencies here. Once added, we have to do only 2 things. Let's go back to application YAML, and what we will need is we will need console configuration. So we will, first of all, the required thing is to enable console registration. We will also specify the default zone, which we will use this format, console host. If this env variable exists, take the value from it. or use localhost, and the same with port, either console port or fallback to this default one. And also one thing that you already learned, console is also using the Micronaut HTTP client. So to avoid blocking the event loop, we're gonna define our own event loop group just right here using IO executor, and we can assign threads to consume only one thread. And last thing, if I keep the URL right here, it will take precedence over whatever comes from console. So I'm going to remove this one from here, and now I can restart my application. Okay. And what happens now is, if we go back to the this endpoint right here, where we were passing the header from the client, you can see here this is the host that returned the response for that specific request, and now it's port 36,000, and now it's port 32,000. So it's just a regular round-robin algorithm. It will pick one after another from available instances. But of course, service discovery does not solve all problems. The real problems happen when there is a problem with communication with the service. And there is this pattern called circuit breaker. And if you work with microservices, you probably have some experience with it, either with Netflix Hystrix or maybe Resilience4j, which you can use with Micronaut. But here we're going to use the default built-in circuit breaker. So quick recap, what circuit breaker is. When the communication between two services works fine, for each method in our client, each method has its own circuit. And when the communication is okay, the circuit is closed. But whenever something goes wrong, like there is an exception that, for instance, a host is unreachable or returns 500 internal server error, the circuit will be opened. And as long as it's opened, our client will not try to call that service again. But after, in Micronaut, it's 20 seconds. Of course, we have the fallback response coming from the circuit breaker client. But after 20 seconds, it will change its states to half opened. And when it's half opened, the next request will try to reach and see if the communication can be established. If it works, it will close the circuit. If not, it will open it again. So let's see how we can add this thing to our system. So firstly, I will just kill those two applications so that we can see what happens if we call users. Of course, we get no available services. And let's fix it with circuit breaker. So for that, we have circuit breaker annotation. There are multiple options you can specify, like you can specify which exceptions cause problems, how many attempts, what is the predicate for the retry. Today we're gonna specify two things. We will change reset to 10 seconds and max delay to 1 second. Okay, and now I need a fallback client. Micronaut makes it really straightforward. So what I'm gonna do is I will implement fallback HTTP client. What we need is, we need fallback annotation. This is how Micronaut instructs that this is the fallback HTTP client. And when we ask, but for which HTTP client specifically, all we have to do is we need to implement the declarative client, right? So for instance, for this method, what I'm gonna do is I'm gonna return OK with empty collection. For the async method, what I'm gonna do is I'm gonna return empty publisher. And for create method, we're gonna go back to it in just a second, okay? So now let's restart the application. Now we have fallback circuit breaker. And what happens now when I try to use our demo application, which cannot communicate with the service, you can see that we get an empty list from our circuit breaker. And for next 10 seconds, whenever I will try to call the same endpoint, I will be retrieving the empty array from the fallback client. And after 10 seconds, it will retry and see if the circuit can be closed. So reading operations are very simple. Returning empty list, returning 404, that's very simple. But as you have seen, the real problem is what happens when we try to create something. And I think this will be the last thing I will show you today. And what we're going to do is we're going to use Amazon SQS. I have a local stack running in a Docker container right now. So what we're going to do is whenever there is a user create requests coming in, we're going to enqueue it to the SQS queue. Thanks to this, if our application dies suddenly, we still have these requests stored on SQS, and we will be waiting until the user's API becomes reachable eventually. When it happens, we will wait for the circuit closed event. This will be the Micronaut event that will be sent whenever the circuit gets closed. We will see if this is the circuit that we are interested in, which has to be the create user one. We will pull up those messages that are stored on SQS, and we will retry it. So for instance, if something goes wrong again, at least we will get again with the fallback client, and they will appear on SQS again. But if everything works, those requests will be handled as expected, okay? So let's do it, and we're gonna use one library from the Micronaut OSS library, which will help us communicating with SQS. And for that, I'm gonna add here one more dependency. This is the last one. I'm gonna add Micronaut worker, and specifically Micronaut worker queues SQS, because this it comes with extra beans that allow me to read and consume messages from SQS. Okay, and before I forgot, I will add one more thing to make this example work. We need to specify and override the SQS endpoint, because as I mentioned earlier, I'm running local stack. So I will just specify the SQS endpoint right here. And now what we need is, let's define our worker job, okay? This worker job has also one significant benefit for us: fallback users API SQS job. It will be also our backup plan if something goes wrong and our application never receives the event that we expect, okay? It has to be a singleton. I will also make it implementing Java functional consumer interface, and what we are consuming is create user request objects. One accept method. Here I'm gonna specify fixed delay, so I want this job to run every 30 minutes. With initial delay of also 30 minutes. And the last thing here, I will add consumes annotation with the name of the SQS queue. In my case, it's create user request. So this job, in the worst case scenario, it will run every 30 minutes, and it will see if there are any messages on SQS to populate and to retry creating users again. And how to retry it? It's fairly simple. Let's inject users API client right here. Okay. I will add some dirty print line, consuming request. And what I'm gonna do is I will just send this request with the HTTP client. So this is our backup plan. Now we need to go back to the fallback, and we need to enqueue those requests to those SQS jobs. For that, we can use final job manager. This is the component coming from Micronaut worker library. When I inject it right here, I can use it to enqueue messages to that specific queue. And that's why I implemented this fallback SQS job in the first place, because I want to use this method with the class type so that I can just pass request. And now this fallback users API SQS job, it also defines the target queue for this, right? And here I will just return a user which has no UUID, which takes name from the request, which takes email from the request, and for created by, I'm going to add fallback, just so that we know that this user was created by a fallback. Last thing, if it comes to this happy path use case, I'm going to add event listener right here. So event listener annotation allows me to create a method that will be triggered on specific Micronaut application events. This event is circuit closed event. The name doesn't matter in this case. What matters is the type, circuit closed event. So whenever this circuit closed event is published from the circuit breaker, we're gonna call this method. I'm gonna add dirty received. I'm gonna see which event is received. And now we need two things. Let me make it a little bit higher so you can see it more clearly. First, I need a method, and I can take it from event get source target method. Now I have to compare it with something. So my expected method, because my client has free circuits at the moment, my expected method is the following one. It's users API client. I'm going to get a method called create. IntelliJ will help me to fulfill all these required parameters. I'm going to add here. And now what I can do is I will do simple equals. So if the method equals expected one, we're going to do two things. First, I'm just going to dirty print saying triggering SQS job, and we're going to trigger it with using job manager. So here we can pass our fallback users API SQS job class. Come on, come here. And that's it. This way, the method and this fallback will be triggered whenever this event comes in. Now it's time to test it. Let's see if demogods are on our site. So let's restart the application. Let's make sure that the application's users API is not running. So let's try, first of all, let's add the first user. Let it be GeeCON with email. We see that the circuit breaker is trying to reach out to users API with no success. So after a while, what we will get is we will get a response from the fallback client. No, we didn't get it. Okay, so it's probably SQS configuration. Yeah, sorry, just I couldn't see it from free measures, so sorry for that. I was about to say that I have eagle eye, but that's not the case, unfortunately. Okay, but there's still some, sorry, one more thing, because it still complains. Yeah, one more indentation here. I hope it's okay right now. Okay. So now we can retry, and we will get we get the response from fallback as expected. Now what we're gonna do is we're gonna start users API, those two instances, back again, and we're gonna test the happy path. Okay, so let's add. First of all, yeah, let's add already here. We are running out of time, so I need to do it anyway like that. So we're going to add another user, Prague, this time. And what you can see is we get the correct response from the user's API. Everything worked fine. But what else happened? If we go back to the console, we can see that, first of all, we received the circuit closed event. We triggered SQS job, and we can see that the SQS job also consumed the message. So if we list users, now we can see that not only Prague user was created, but also the GeeCON one. So it's not like a silver bullet that this is the only way how to solve issues, because maybe sometimes you don't want to do anything when you get those requests, when you cannot communicate. But this is one way how to do it. I won't show you the bonus part. The bonus part, basically, I can only reveal to you what the bonus project contained. And if you ping me on Twitter, I will show you exactly how to do it. Because here what we have is a Spring Boot application. And cherry pick on Cake was just to use the same HTTP client with no changes, with the same circuit breaker in a regular Spring Boot application. But unfortunately, we ran out of time. So quickly, let's summarize. We explored those features from the Micronaut framework. I hope you see the benefits of the declarative HTTP client, as well as these traps, especially if it comes to thread pools, especially if it comes to how to utilize those clients correctly. We didn't see the fireworks. And let me just quickly take a look if there are, I can answer maybe one or two questions if you posted any. There are some. Is there a graphical client available for Micronaut? Nothing I know about, so no, I think not. Is Micronaut compatible with Maven as well? Yes, and it also has some plugins for AOT compilation. Gradle has better support for that, but you can generate application with Maven as well. Any compatibility of Micronaut with Jakarta? No, it's not Java EE compatible framework. How will the throttling work when virtual threads are used? You can't use virtual thread at the moment, so there is no answer to this question as well. But I guess maybe in the future, especially when the Project Loom is out of the preview, you can expect some updates on that. So that's all from my side. There is one more thing I would like to just tell you. If you are interested in all things Micronaut, I have this project called the Yemen Files. I share on Twitter those very short, bite-sized pieces of all things Micronaut. If you are interested, I strongly encourage you to check out my Twitter feed. My name is Szymon Stepniak. I work as a platform engineer at Agora Pulse, and I'm self-claimed Micronaut framework ambassador. It was nice to talk to you. Thank you very much. Have a nice day.